In this example, I would like to show you how we're going to use the t-test to determine if two different sets of data are significantly different. I've added a little bit of template here in an Excel spreadsheet, so I encourage you to put this on pause first if you want to draw out the template here. Also notice that a couple of the equations later on are really complex, a little cumbersome in Excel. This is the relevant equation in our Harris 8th edition textbook, and this is where these cells are going to go in these equations. So again, you can put the movie on pause if you are following along, and you should be following along because I'll want you to be able to do this. So let's start off with a little bit of data. These are weights of M&M candies that were measured by two different students on the same balance. It's the same set of same piece of candy, and it is replicates. The units are in grams. There, and I think I didn't make any mistakes there. To start off with some basic statistics, if we want the average or the mean, we're going to type in equals average. I'm going to go up here and just highlight that. If I want the standard deviation, stdev. The variance, and I'm going to put this in because it makes these equations a little bit more manageable, is the square of the standard deviation. So I am just going to put in the above caret 2. And for the same reason, let's put in the number of data points. We'll count the number of values in an array. There we are. And then the coefficient of variation, which is also the relative standard deviation, just for fun, times. There we are. Now if I want all of these values, the corresponding values in column C, I'm going to highlight, and then notice on the right hand side, lower right hand corner, my cursor changes from a large white plus to a smaller black plus. I can click and drag over, and the relevant values have been updated. So here, what I want to start with is just type in the confidence level. We're going to use a 95% confidence level, and that gives us a p-value of 0.05. First, let's start off with the f-test. The f-test is going to help us determine whether these two variances vary significantly. To do that, we're going to take first we're going to calculate the ratio of the squares of the standard deviations. And I'm going to make this equation just a little more complicated so that the value that we get is always going to be greater than 1. Get 13. Great. Now, we have the table. So that's the value that we calculated. Whoops. You know what I'm going to do here? I'm just going to bring these down into that column just so I keep myself on track. Looking at some notes here. Now to calculate or extract the value from the table, that function is called finv. C13. And then the 2 degrees of freedom, and if this value is greater than this value, then that means the variances are significant. I'm going to do a little cell here that that helps me remember it, because sometimes things get confusing. So I'm just going to put that right in. B16 is greater than D16. Great. So that function, that cell will tell me automatically that whether or not these two values are significant, and whether the variances are significant. In this particular case, they are not. You just do a little test. See if we put in a bizarre value there, it will automatically change. Press Ctrl Z, get back. Now we can use the t-test to figure out whether or not the difference between the means is significant. The f-test that we just performed allows us to use the t-test for equal variances. So let's start off right there. And since I have the equations for B19 and B20 already set up, I'm just going to use these right here. You can pause the video at this point to grab these functions if you would like. So this gave us our calculated t-value, and to grab the t-value from the table, that's the tinv function in Excel. It asks for the probability, which we have in C13, and then it asks for the degrees of freedom, which in our case is the sum of the individual measurements minus 2. Oops, I made a mistake there. Yes, I made a mistake. I put the wrong numbers in. There we are. Okay. Now, what do we do with these two numbers right here? When we compare the t-calculated and the t-tabled, if t-calculated is greater than t-table, then the difference is significant. So let's make a cell that helps us clarify that. If t-calculated, which is this value, is greater than t-table, the difference is significant, which means if they're not, then the difference is not significant. So what this is telling us is that the weights, or the average weight determined by the first student and the average weight determined by the second student, are statistically different at the 95% confidence level. So even though the two students in this particular case weighed the same M&M and they used the same balance, they did not get the same result. Now, let's just finish up this this Excel spreadsheet so that we have a template for subsequent experiments to account for cases where the f-test says that the variances are significant and you need to use unequal variances. What we'll do is you can put this on pause again, and we're just going to take these equations, plug them in. Again, take a look at your Harris textbook. Those are the equations, to get an idea of what these equations are, what they look like. B25. And again, T inverse. And this time, the probability is the same, but since we just calculated the degrees of freedom in the unequal variances, we use that. Let me see, it's slightly different. We can take this equation to this little helper cell, copy it, and paste it. It will automatically change the cells that it's comparing, and since we organized these two cells in the same fashion, it does what we expect it to. And this result is not relevant for our particular set of data. But if we had a set where the f-test showed that they were significant, then we would be looking down here. So there we go, a t-test in Microsoft Excel with a set of data that we can vary, and so and that will update the rest of the results for us. It's a little more flexible than using the data analysis tool that is typically used in these types of experiments.